Hello everyone, welcome to Pay1 Tech Media. In this video we are going to learn about subnet mask. So what is subnet mask? Well, in IP address Internet Protocol version 4 we have default subnet mask or class full subnet mask, and we do have a classless subnet mask. Well, a subnet mask determines what section of the IP address belongs to the host and what section of the IP address belongs to the network. So basically by the use of subnet mask, we can tell how many subnets do we have, how many available IP addresses per subnet we have. So it is very important to understand the purpose of subnet mask and how can we calculate the subnet mask. So in this video first we will talk about the default subnet mask, and in the next videos we will talk about classless subnet mask. We will go over some examples as well. So stay tuned and let's go ahead and jump into the computer and take a look. Before we get into the subnet mask, what is the purpose of subnet mask? It basically determines what section of IP version 4 belongs to the network and what section of the IP address belongs to the host. For example, when we have IP address of, let's say, 192.65.32.18, so looking at this IP address, first octet 192 falls into class C. So what is the default subnet mask for class C? It basically, the first 3 octets, it's for the network, and the last octet, it's for the host, which we will talk about it more. So that's the purpose of subnet mask. It gives us information what section belongs to the network, what section belongs to the host. Okay, first we will talk about class full or default subnet mask. For class A, B, and C, we have subnet mask. For class D and E, we don't have subnet mask address because class D, it's mainly for multicast purposes, one-to-many defined groups of communications. For class E, scientific and research purposes. So let's go ahead and talk about class A address. The default subnet mask for class A is 255.0.0.0. That's default subnet mask for class A. What does this mean? Means that in the first octet, class A, all the 8 bits are turned on. So for class A, if I write down all the bits here for the subnet mask, we have the first octet all turned on. And the rest, it's pretty much all turned off. These are the subnet mask address. And 1s represents the network bits, 0s represents the host bits. So if I ask you a question, for class A, how many octets do we have for network? Only 1, the first octet. So 1s represents the network bits and 0s represents the host bits. Therefore, we have 8 bits for network and 24 bits for host. You might see also this CIDR notation /8 CIDR. Classless interdomain routing, which we will talk about it more when we get to the VLSM or the classless subnet mask. So this /8 means that 8 bits fixed, 8 bits for turned on, 8 bits for the network. So the first 8 bits turned on, it gives us 255. If you remember previously we talked about anytime when we have 8 bits, all the 8 bits turned on, the value, decimal value is 255. So here this 8 bits on the second octet, it's all 0. That's why here on the second octet, when we convert the binary to decimal, we see it's 0. On the third octet, we have 8 bits, all 0. So here, converted to decimal, we have 0. And the last octet also the same, 0. So for class A, default subnet mask is 255.0.0.0, and the CIDR notation we can write /8. This /8, it's basically telling us the first 8 bits turned on. It's a network bits, and the rest turned off. So this is default subnet mask for class A. Now let's go ahead and talk about class B. Default subnet mask for class B is 255.255 0.0.0. What does it mean? It pretty much means the first and the second octet, it's all turned on. So we have 8 plus 8. Let me erase all this. 8 plus 8. So 8 ones plus 8 ones, and then 8 zeros, 8 zeros. So it gives us 255.255.0.0. The shorthanded version or the side notation is 16, because if we count, this is the number of bits being turned on. So from left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is /16. 16 bits turned on gives us 255.255.0.0. What does it mean? For class B, we have 16 bits for the network, 16 bits for the host. So ones represents the network bits, zeros represents the host bits. Now let's move on and talk about class C. For class C, default subnet mask is 255.255.255.0, and the shorthanded version or the side notation is /24. What does it mean? It means that for class C, we have the first octet, second octet, and the third octet all turned on. So these are the default subnet mask for IP version 4. For class A, 255.0.0.0, only 8 bits for the network. Here we can see the first octet. And for class B, we can see 255.255.0.0, 16 bits network. For class C, we have 255.255.255.0, so that's 24 bits for network, therefore 8 bits for the host. If we count 1, 2, 3, 4, 5, 6, 7, 8, 8 zeros. So zeros is host bits, ones network bits. 24 plus 8, that's a total of 32. And that's what we see here in IP version 4, there are 32 bits. So these are the default subnet masks for class A, B, and C. So please keep in mind, we don't have subnet mask for class D, and we don't have subnet mask for class E. So here I'm going to write down multiple IP addresses. Let's say 194.18.32.16. Let me write down another IP address, 194.18.15.21. So if I ask you a question, these IP addresses, what class are they? Very good. Looking at the first octet, 194, we can tell what class this is. 194 falls into this range, between 192 to 223. So therefore 194.18.32.16 is class C address. Also this one, the 194, falls into this range, so that's also class C IP address. Next question, are they on the same network? They are on the same class. Yes, 194, class C. But are they on the same network? They are not, because looking at the default subnet mask for class C subnet mask is 255.255.255.0, means that the first 3 octets must match. So here 194, very good. Very good. First octet is matched. 18, very good. The second octet matched. 32, 15. The third octet, it's not matched. So looking at the network portion of these IP addresses, we can tell that it's not matched. Because for class C, the first 3 octets must match. Here, only 2 of them matched. 194 is class C, yes, but they are not on the same network. Therefore, computers cannot ping this computer. It's not on the same network as this computer IP address. How do we know they're not on the same network? So looking at the IP address and based on the subnet mask, the default subnet mask, we can tell these two IP addresses, they are class C, and the default subnet mask for class C is 255.255.255.0. It means that the first, second, and the third octet must match. 194, the first matched, 18, the second octet matched, 32.15, the third octet not matched. So these two IP addresses, they are not on the same network. And these addresses here, known as a host address. So one computer, let's say .16, the other computer .21. Okay, I'm gonna go ahead and write down another IP address. Let's say 194.18.32.51. Again, we know this is class C because 194 falls into class C range. Here, as we can see, 194, it's between 192 to 223. And this is the range for class C. And the default subnet mask for class C 255.255.255.0. So the first three octets belongs to the network, the last octet belongs to the host. And the first three octets must match. Let's see. So 194, very good, matched. 18, matched. 32, matched. Very good. So these two IP addresses, they are on the same network. They are on the same class and same network. But all these IP addresses, they are only on the same class. This IP address, it's not on the same network as these two. So here we can see the main purpose of subnet mask, and we can tell that how important it is when we talk about subnet mask. It determines what section of the IP address belongs to the network and what section belongs to the host. And another thing that we need to keep in mind, in the host portion, for example, if this IP address 194.18.32.51, if this was .16, and because here we have .16 already in use, and if these two IP addresses belong to the computers on the same network, same location, this is considered as duplicate IP address. That's not good, because in every local area network, in every LAN or segment, or let's say every room, all the computers or devices must have unique IP address. If we see two devices that using the same IP address, it causes IP duplicate, and none of the devices can communicate on the internet or on the network. So these two IP addresses, they are class C and on the same network because the network portion exactly matched. Therefore, the host portion also is unique, it's not duplicated. So it's a valid IP address and on the same network, and these two devices should be able to ping since they are on the same class and same network. Okay, let's have a couple more examples. Let's say this time we use, for example, 129. 129.81.16.15. Another IP address, let's say 129. This looks like 8L. Let me erase. This is 1. Okay, 129.81.16.19. This one, 129.81.121.15. So if I ask you a question, are these IP addresses on the same network? Can they ping each other directly without going through any router? And the correct answer is yes. Very good. Because first we want to find out what class are they, right? So looking at the first octet, 129, 129, 129. So this is class B because 129 falls into this range and it belongs to class B. And because they are class B, now we need to take a look at class B default subnet mask, which is 255.255.0.0. It means the first 2 octets belongs to the network and must match, must be exactly the same. And the last 2 octets are for the host, and it has to be unique. Okay, so here we can see the network portion and the host portion. The network portion in class B, 255.255.0.0, the first 2 octets must match. 129, 129, 129, very good. 81, 81, 81, very good. Therefore, all these 3 IP addresses are on the same network, and they are also on the same class, 129, 129, 129, and same network. And here we can see it's unique. 16.15, 16.19, 121.15, very good, they are unique. Okay, at this point, any IP address when I write down, you should be able to tell me what class this is and if they are on the same network, yes or no. So I'm going to write down, let's say, 132.18.9.54. 132.18.16.119. 154.16.19.25. Okay, let's take a look. Here we can see 132, 132. So these two 132 falls into this range. It's class B. 154 also falls into this range. Therefore, it's class B. So all these IP addresses class B IP address. And default subnet mask for class B 255.255.0.0 means the first 2 octets must match. So for class B, the first 2 octets belongs to the network, the last 2 belongs to the host. So 132, 132, 154. So 132, 132, 154. So 132 and 132 it's matched, 154 it's not matched. Now let's move on to the second octet, because again in class B, the first 2 octets must match, right? 255.255.0.0. So the first octet, so far the first 2 IP addresses matched. This one not matched. And the second octet, 18, 18, 16. So we know this 18 matched with this 18, and this 16 not matched. So we know these 2 IP addresses are on the same network, because the network portion, it's matched. All the IP addresses are on the same class B. So keep in mind here also, if we had 18, still it wouldn't be on the same network because the 154, it's not matched as 132. Or here if we had 132 and here different number, still wouldn't be matched because both of the octet must be matched. So it has to be 132.18 to consider being on the same network. And here we can see the host portion are unique. So these 2 IP addresses, class B on the same network, unique IP addresses for the host, they can communicate. And here the last one, it's class B on different network because of this 154.16. These 2 devices can ping directly through the switch. This one, if any of these devices wants to talk to this one, has to go through the router if, again, default gateway address, IP addresses scheme set correctly, all that stuff. But it has to go through the router. It's not on the same network. In the next video, we will talk about some of the examples of default subnet mask for class A, B, and C. Thank you so much for watching and have a good day.